The Nature article, Robust Warming of the Global Upper Ocean, determined the average amount of energy the oceans have absorbed over the period 1993 to 2008 is enough to power 500 100-watt light bulbs for each of the 6.7 billion people currently living on the planet, which equates to 330 terawatts annually. Current world consumption of primary energy from all sources is about 16 terawatts. This heat is being stored in the ocean due to a global radiative imbalance exacerbated by increasing greenhouse gas accumulations. Since the mid-1950s, the oceans have absorbed 18 times more heat than has been absorbed by the atmosphere. Eventually, however, in accordance with the second law of thermodynamics, these two bodies will have to reach equilibrium, and this time frame is estimated to be about 1,000 years. Most of the electricity we consume is derived from boiling water. The means of boiling this water, whether it is nuclear power or by burning hydrocarbons, bring with it consequences which cannot lucidly be discounted, and yet by our actions that is precisely what we are doing. For the sake of our immediate gratification, we are foisting horrendous consequences on our children. As it turns out, it is not necessary to generate any additional heat to produce all of the power we will ever need. The heat stored in the upper layers of our oceans, which is available 24/7, is causing thermal expansion and sea level rise, as well as melting of the polar ice caps, which further contributes to sea level rise. It is sufficient to boil liquids such as ammonia and propane, and these vapors in turn can spin a turbine to produce electricity. The way, therefore, to prevent the collapse of the West Antarctic ice sheet, forecast by the Canadian study and elsewhere, is to convert the ocean's excess heat to carbon-free sustainable power. Ocean thermal energy conversion, or OTEC, is the method by which this is accomplished. OTEC uses the temperature differences between cooler deep and warmer surface waters to run a heat engine to produce useful work, usually in the form of electricity. The first law of thermodynamics dictates that the increase in the internal energy of a system is equal to the amount of energy added by heating the system minus the amount of energy lost as a result of the work done by the system on its surrounding. A useful way to consider the amount of energy available in the oceans is to consider a hydroelectric dam. Temperature differences are analogous to the hydraulic head behind the conceptual dam. Each degree centigrade corresponds to an additional 427 meters worth of height for the dam. The best locations for OTEC power have around 21 degrees difference in temperature between the surface and deep waters, which in our example would correspond to a dam of a height of 8,967 meters if you could convert all of the dam's potential. Because of the low thermodynamic efficiency of a Carnot cycle with small temperature differences between the hot and cold reservoirs, however, the best that you can get from ocean temperatures is about 7% conversion. In practice, this is closer to 2.5%, which still equates to huge expanse of ocean lying behind an invisible thermal dam of a height of 224 meters, which tops Hoover Dam by 3 meters. Continuing with the dam analogy, we are continuing to increase the thermal head of our oceans by 330 terawatts of heat every year. With the consequence, we are inevitably going to breach our ocean dam with significant consequences. The insurance company Allianz has forecast sea level rise will place $28 trillion worth of property at risk in the world's largest coastal cities by 2000.